What's up, people? Welcome to today's session. How are you guys doing? I hope all of you guys are doing good. Taking care of yourselves, staying safe, and being good kids, not troubling your parents a lot. Anyways, welcome to the Prodigy session of light, where we are going to be talking about laws of refraction and refractive index. Both of these topics are super duper important, and it's definitely going to appear in your term one examinations. So I'm hoping that you guys have started your preparations already, because guys, you can't take it leniently anymore. You have to put in the effort, because it's not a one term examinations anymore. It's a two term examination. That means that you have to be active throughout the entire year. Every exam, every unit test, every class test, all of it matters right now, right? So anyways, my name is Anoop Manoharan. To introduce myself, I am an aerospace engineer by profession. I've been teaching for the past 5 years now. In that 5 years, I've had the pleasure to teach more than 10,000 students all over the country, and I've helped majority of them score 90% and above. So that's a little bit about me. Apart from that, I'm a big sports enthusiast. Mostly I like football. I'm not a big cricket fan, to be very honest. I know there'll be a lot of haters for this statement, but I'm not a big cricket fan. I'm from Kerala, but I was born and brought up in Bangalore. So that's all about me in one single introduction. Yeah, that's pretty much it. And yes, people, yes, to today's topic, right? So we are going to be starting off this session with a very simple riddle, just to kickstart your brains a little, because I know that a lot of you guys are in different situations right now. Some of you guys would have just woken up, some of you guys have been sitting in front of the computer for the past 2-3 hours now, and you're watching this video just to get that information. So just to relax your brains a little, just to kickstart your brains a little, here's the riddle for today. The riddle is very simple. Gaze at the sentence for just about 60 seconds and then explain what makes it quite different from the average statement or sentences. Be quick. What is it? Let me know what is the answer in the comment section. Let's see who gets the answer for this question the fastest. Do not Google. You have 1 minute time. But again, guys, do not Google. I want you guys to put on the answer. It's a very interesting riddle. Let's see how many of you guys would solve this one. I have a couple of announcements to make as well before I get started, guys. As you guys know, we have already done a couple of sessions related to light, a lot of which is already present. It's already uploaded, so make sure that you check out those videos if in case you have doubts in any of these topics that we've done 2 sessions for numericals, which is going to be super duper helpful, so make sure that you check those out as well. And yes, guys, we have the Telegram groups open for you people for Vedantu 9th and 10th English channel. So if you guys are already a part of it, do not forget to subscribe to the channel first, and if you guys already have subscribed, you can also join the Telegram group to get faster notification, to get in touch with all of your master teachers, and also to get the regular schedules of all of the sessions that comes ahead. And to make it all better, people, I have already launched my pro exclusive micro course, which is going on the Vedantu platform as we speak. I'll tell you the details of it as we go ahead, but right now as we speak, master electricity like never before is going on. So if you want to study with me on the Vedantu platform, I'll tell you how to do that as well. I also have a lot of master classes going on Vedantu's platform, which is completely free. So if you guys are into it, guys, if you want to have extra knowledge, if you want to have some clarifications on certain topics, those master classes are also something that you can look forward to, and you can enroll for that as well. It's completely free. The master class is completely free. I'll tell you more about that as well as we go ahead, right? So anyways, guys, let's get started with today's session without wasting any more time. I know there's a lot of notifications, but let's get into the topic. So guys, here's the thing. For all those who watched the previous session, we had started with this topic called as refraction. And one of the ways that I explain refraction is when a car is going from a tar road onto a muddy road. What happens is that the tire that comes in contact with the mud first would slow down a little, and hence the car would slightly change from its original path. And in the same way, I told you that light also, when it's traveling from one medium into another, it slightly deviates from its original path, and that is what is called as refraction. That is the change in the path of light when light travels from one medium into another. That is what is refraction. So the ray of light that is coming and falling onto the surface is called as the incident ray. That is a ray of light that is coming and falling onto the surface, and the ray that changes the direction is what is called as a refraction tree. And then you have basically a perpendicular line that is drawn with respect to the surface, sorry about that, which is what is called as your normal. That is what is called as a normal. Now, a couple of things that you guys must be aware of is this, people. One of the things that you should be, that every one of you guys must know is what is called as angle of incidence and angle of refraction. Angle of incidence is nothing but the angle formed between the incident ray and the normal. Now it's the same, angle of incidence like how you would refer to it in the case of reflected rays as well. So it's the exact same thing. The angle formed between the incident ray and the normal is called as the angle of incidence, which is generally represented by the letter small I. On the other hand, the angle formed between the incident ray and the refracted ray, the ray of light that undergoes refraction, that changes the path, that is what is called as angle of refraction. All right. So you have angle of reflection in the case of reflection. In the case of refraction, it's called as angle of refraction. So you have angle of incidence, angle of refraction, both. Again, guys, with respect to the normal, it is not with regards to the medium. It is not this angle, but it's rather this particular angle. All right. Anyways, guys, these are the things that you've already studied in the past. If you've been with us, you would already, when we talked about mirrors, we've already talked about angle of incidence and angle of reflection. So this is just an add-on to that. So I'm hoping that you guys know about it. Now, guys, here's the thing. Every ray of light that undergoes reflection, I mentioned this, that they will all follow the laws of reflection. In the same manner, people, a ray of light that is refracting will also follow certain laws. And the first law of refraction is actually the same law of reflection. The second law of reflection is actually the first law of refraction. Remember the second law of reflection? It is nothing but the incident ray, the reflected ray, and the normal all lie on the same plane. In the case of refraction also, it's the exact same thing. The incident ray, the refracted ray, and the normal will all lie on the same plane. The only difference is this. Over there, it's the reflected ray. Here, it is the refracted ray. That is the only thing. So all of these would lie on the exact same plane. Now, if you haven't understood this particular concept, guys, I have already made a video of it. So make sure you check that out, because trust me, people, I've explained that very, very clearly over there. So hopefully you guys would get that. So check those out. I think that is the first or maybe the second video of light. So make sure you check that out as well. I've explained that in depth. Right, moving on to the second law now. The second law basically shows you the relationship between angle of incidence and angle of reflection. So angle of incidence I divided by the ratio of angle of incidence to angle of refraction, I divided by R, is equal to the velocity of light in the first medium. See guys, light is coming and falling from air into glass. Light is entering from air into glass. So air is the first medium and glass is the second medium. Speed of light in air is different. Speed of light in glass is also different. That is why the light is refracting. So whatever is the velocity of light or speed of light in air divided by the velocity or speed of light in glass would give you a certain relationship. Now, what is that? Let me tell you that in a minute. So here's the thing, guys. What you're supposed to do is you're supposed to take the sine of angle of incidence and the sine of angle of refraction. Now, a lot of you guys would be, sir, what on earth is sine? See, guys, sine is nothing but a trigonometric value. Now, it's in your math, you'll study about trigonometry later on. Some of you guys would have already done that in school. Some of you guys might not have gone to that part yet. So, sine is basically a trigonometric ratio, which is nothing but opposite divided by hypotenuse. That is the basic definition of sine, right? It's a trigonometric value or trigonometric ratio, which is nothing but opposite to hypotenuse, right? So if you have a right angle triangle, and this is theta, let's say, so opposite to hypotenuse is what is your sine. So if I take the sine of angle of incidence to the sine of angle of refraction, whatever value I get, that is going to be a constant. This is what your second law of refraction says. I know it's a little confusing. Let me say that again, guys. So guys, first of all, just to give you a little bit clarification. So the sine theta is nothing but your angle. Theta is nothing but the angle. So in this case, it'll be sine I, which is nothing but your theta, divided by sine R, which is nothing but your theta. Instead of a theta, you're putting it as I and R. That's all. So as you can notice, this is the table. This is the table of sine, right? So sine 0 degrees is 0, sine 0 is equal to 0. Sine 30 is 0.5, that is 1 by 2. Sine 45 is root 3 by 2, which is nothing but 0.7. And sine 60 is 0.86. And finally, guys, sine 90 degrees is nothing but 1. So you can notice that as the value of theta increases, sine theta value also keeps on increasing, right? As the theta increases, that is as the angle of incidence and as the angle of refraction also increases, your sine theta value for those would also keep on increasing. All right. Now, listen to me carefully. According to second law of refraction, the sine of ratio, or the ratio of sine of angle of incidence, to the sine of angle of refraction is basically a constant for two different mediums, or for a set of two mediums. Let me explain that in a better sense. See guys, let's say that light is traveling from one medium to another. Let's say light is traveling from, glass to water, or let's say water to glass, whatever medium you want to take. Now the speed of light in all of these mediums are constant. For example, the speed of light in vacuum is 300,000 km per second. Speed of light in air is 2,999 or 2,99,000 km per second. My God, I'm so sorry about that. Anyway, so ice, it is 2,209, 200. My God, what is happening? All right. I don't know what's happening, guys. I have no idea what's happening to me. Anyways, so that's 2,29,000 km per second, and then it's 2,25,000 km per second, and then it's 197,000 km per second. So what I'm trying to say is this, people: the speed of light in these mediums are constant. So let's say that light is traveling from air to water. Speed of light in air is also constant. Speed of light in water is also constant. So every time you divide the speed of light in air to speed of light in water, you will get the same value. So basically, every time you divide it, it'll be what? 2,99,000 km per second divided by 2,25,000 km per second. Every single time you'll do the same thing. So the speed of light in a certain medium is fixed. Because of this, people, when you find the ratio of sine of angle of incidence to the ratio of sine of angle of refraction, it will be equal to what? The speed of light in the first medium divided by the speed of light in the second medium, which is a constant, because the speed of light in the first medium, whatever the medium that is, and the speed of light in whatever medium that you take, be it air to water or water to air, whatever the two mediums are, it is going to be constant because the speed of light in those mediums are constant. So the simple explanation for this is, guys, the ratio of sine of angle of incidence to the sine of angle of refraction is going to be constant for a pair of medium. This is what is called as your second law of refraction, which is also known as Snell's law of refraction. This is what is called as Snell's law. All right. So sine I divided by sine R is equal to velocity of light in the first medium divided by the velocity of light in the second medium, which is nothing but a constant. And this constant is what is called as your refractive index. That constant value that you get, the speed of light in one medium divided by the speed of light in the other medium, that is equal to n, which is nothing but the refractive index of a medium. So what is a refractive index? Another question. Refractive index is nothing but, guys, it tells you by how much a ray of light is bending in a medium. Let me repeat it. Refractive index tells you by how much a ray of light is going to bend in that particular medium. If the refractive index is more, the bending of light is going to be more. If the refractive index is less, then the bending of light is going to be less. And the formula to find out the refractive index is N is equal to C by V, where C is nothing but the speed of light in vacuum divided by the speed of light in the particular medium, be it glass, be it water, whatever is the medium that you're going to take. So when you have the speed of light in that particular medium, if you divide it by the speed of light in vacuum, you will get what is known as the refractive index. And this has a specific name. This is called as absolute refractive index. What is it called as? This is called as absolute refractive index, because speed of light in vacuum is constant. Its speed of light in vacuum is always going to be 3 into 10 to the power of 8 meter per second. It's not going to change. It's always going to be constant. So keeping that in mind, people, this is called as absolute refractive index, because you're comparing the speed of light in vacuum, which is a constant value, to the speed of light in whatever medium you take. This will give you the refractive index of that particular medium, and this is called as absolute refractive index. But you have another one as well. There's something else called as relative refractive index as well. Now, to give you an example, guys, the refractive index of diamond is 2.42. What does this mean? This means the speed of light in vacuum, basically n is equal to speed of light in vacuum, that is 3 into 10 to the power of 8 meter per second, divided by whatever is the speed of light in diamond. So when you divide that value, you will get the refractive index as 2.42, which is the absolute refractive index of diamond. In the same way, people, you also have something called as relative refractive index. For example, see guys, light is not always, when you take two mediums, you can't always compare with vacuum, because on the surface of the earth, there is no vacuum at all. You always have light traveling from either air to water or water to air, or air to glass or glass to air. Something or the other is happening. So over here, you have to compare the two different mediums. So relative refractive index is nothing but refractive index of a medium with respect to the other medium. So for example, guys, refracted, let's say that light ray is coming from one medium to another. So this is medium 1, where the velocity of light is v1, and this is a velocity of light v2, all right, in the second medium. So refractive index of medium 2 with respect to medium 1, that is what this means. N21 means speed, the refractive index of medium 2 with respect to medium 1. That is what it really means. So if I want to find out what is the refractive index of medium 2 with respect to medium 1, I need to know what is the refractive index of medium 1 and refractive index of medium 2. So that the formula becomes what? N21 is equal to refractive index of the light in medium 2 divided by this refractive index in medium 1. All right. And if I do not have the refractive index, at that time I can use the velocity of light wala formula, which is nothing but velocity of light in the first medium divided by the velocity of light in the second medium. So if you know this case, again, you can find the relative refractive index of two different medium. All right, guys. So yeah, this is what it looks like. So if you see that the velocity of light in the first medium is greater than velocity of light in the second medium, then the first medium would be the rarer medium and medium 2 would be the denser medium. If it's the other way around, then you can say that the medium 2 is rarer and medium 1 is denser. Now, one more thing, people, if you see that if your refractive index of medium 2 is, compared to medium 1 is less than 1, then again you can say that medium 2 is rarer and medium 1 is denser. Because again, guys, N21 is equal to what? N2 divided by N1, refractive index of the second medium divided by the refractive index of the first medium. So you can say that if you find that the value of the ratio that you get is less than 1, then you can also come to the conclusion that the refractive index of the second medium is less, which means that it's a rarer medium, or the speed of light is much more lesser in that, and speed of light in the first medium is much more higher. I know it's a little confusing, but again, guys, that is what it is, right? So once again, just a quick revision, people, what all we have seen so far. Once again, refractive index is nothing but a quantity which helps you to decide, or which tells you by how much a ray of light is going to bend. Because here's the thing, guys, in some mediums, the ray of light is going to bend more, whereas in some, it is going to bend a little less. So this refractive index helps us to compare that, in which of these medium light would bend more, and in which of these light would bend less. And what is Snell's law? Once again, Snell's law is nothing but, or second law of refraction is nothing but the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a pair of medium. So the formula is what? Sine I by sine R is equal to V1 by V2, where sine I is nothing but the sine of angle of incidence, sine R is nothing but the sine of angle of refraction. Velocity of light in the first medium is v1, velocity of light in the second medium is v2. And this value that you get, v1 divided by v2, is going to be a constant, and that constant is what is called as refractive index. And what is refractive index? I've already explained that. There are two types of refractive index. One is absolute refractive index, the other is relative refractive index. Absolute refractive index is when you compare the speed of light in vacuum to the speed of light in that particular medium. So then it becomes what? N is equal to C divided by V, where C is the velocity of light in vacuum divided by the velocity of light in that particular medium. And then you have relative refractive index, which is nothing but a comparison of the refractive index of two different medium. So you would write it like this. So for example, if I want to find out what is the refractive index of the second medium with respect to the first one, then it'll be N21 is equal to refractive index in the second medium divided by the refractive index in the first medium. And also, if the refractive index is not given, you can use it, you can find out by finding out the velocity of light. So velocity of light in the first medium divided by the velocity of light in the second medium. You can take a screenshot of this. Please do remember it. Super duper important. You might be, expected to answer these in your examinations as well. Right, guys? So those were the topics that I had to teach. Now I'm going to test your knowledge with a quick quiz time. But before that, guys, let me make a couple of super duper amazing news that has come out just now, people, and that is that we have produced more than 100 plus results in the NTSE. More than 100 plus students from Vedantu have cleared NTSE stage 2, which is an absolutely spectacular news, because no institute in the world or in this country, in fact, has produced that type of results. So yes, people, the topper ka naya address is what is Vedantu. You can get all of the subjects from physics, mathematics, biology, mental ability test to social science. Now again, still studies. Now again, guys, you would not only get the NTSE whole crash course, but this would also help you for your exam preparations. When you're preparing for your boards, this will also come in handy for that as well. To be very precise, about 139 selections have been done so far, and we're still counting, with 60 plus hours of live classes, with 50 plus chapter wise tests, 14 plus mock tests, and all of these sessions will be recorded, so you can watch it anytime, anywhere. So let me just quickly show you how all of this is happening. Oh my god. All right, let me just close all of that up first. Okay, so yes, guys, so this is one of the videos that came out recently. So let me just go to what you have to do is, since you guys are watching the video, so what you do is, guys, click on register to Vedantu Pro right now. Click on this link, and that link will take you to Vedantu page. This is what it looks like. So what you do is, guys, click on this change and click on your NTSE preparations. You can go for NTSE crash course over here. Click on that, and you can check out that there are two different crash courses. One is Vedantu Light and the other is Vedantu Classic. The only difference between these two is that in Vedantu Light, you have no doubt solving outside the class. That is, doubt solving on mobile phone is not, the mobile app is not available, but that is there in Classic. So the price difference is also very, very minute. So you have 4,050 rupees for the crash course for NTSE Light, where you have live interactive sessions, test series and assignments, doubt solving inside the class, but you don't have the doubt solving app. In Classic, people, you have the doubt solving app, as well as the rest of the things that are meant to be. That is your live interactive sessions, test series and assignments, all of it, with about 5,000 rupees for the whole complete micro course, right? These are all the amazing teachers who's going to be teaching you, who have produced some amazing results, as you have already seen. And you can check out which are the days that the batch is starting, and these are all the results, and you can see that for yourself, right, guys? So yeah, that's the link right there. With that said, let's get back into the quiz time right now, because I want to see how many of you guys are able to answer these questions. So let me know honestly, guys, in the chat box, in the comment section, if you guys are clear with the concepts. If there's any any confusions in any of these concepts, if you want me to repeat it, please let me know. Maybe I'll try a different ways to explain the same particular concept. So let me know that in the comment section. And apart from that, guys, let me also know how these questions are. Do you guys want me to increase the toughness of the question, or are these questions good enough for you people? Is it helping you? Let me know all of that in the comment section as well, so that I can modify it accordingly, because ultimately, guys, it's for you people, it's not for us, it's for you guys guys. So let's make the best out of these sessions, right? So yeah, guys, here's the first question. Let's go, people. The question is quite simple. Here it is. The refractive index of medium P is 1.2 and the other medium is 1.9. Which of the two is the denser medium? Options are medium P, medium Q, both, or can't say. Super easy question, guys. Go ahead and answer this. I'll give you 5 seconds. If you want more time, please feel free to pause the video because it's a premiere session. So pause the video and then go ahead and answer the question, right? I'll give you 5, 4, 3, 2, 1. The answer, guys, should be medium Q. You know why? The greater the refractive index, the more the denser the medium is. That means light would bend furthermore in that medium. So in medium Q, light would bend more compared to medium P. All right, so that is what it is. Next one. Glass has a dash index of refraction than air. Equal refractive index, greater refractive index, less, or impossible to say. Super duper easy question. Super duper. It's one of the most basic questions that they can ask you. Glass has dash index of refraction than air. In 5, 4, 3, 2, 1. Definitely greater, people. Glass for sure is one of the densest, one of the densest medium that you have. So yes, it has a greater denser medium. It is much more denser. It has higher refractive index than that of air. So that is the answer. Next one. The measure of how much light refracts is called as what? The measure of how much light refracts is called as what? Refraction, laws of refraction, refracted ray, or the index of refraction. The measure of how much, I've already mentioned this, guys. Let me know what is the answer in 5, 4, 3, 2, 1. The answer is the index of refraction or refractive index. That is what tells you by how much a ray of light is going to bend. Next question, guys. Here it is. The formula to calculate the refractive index is what? What is the formula to calculate refractive index? Is it N is equal to CV? Is it N is equal to V by C? Is it N is equal to C by V? Or is it V is equal to NC? What is the formula to calculate absolute refractive index? You know the answer, people. I'll give you 5 seconds. Again, let me know what is the answer in the comment section, and let me know if you guys need a tougher question, if you want tougher set of questions to be asked in those quiz times, so that I can modify the questions accordingly. I'll give you the answer in 5, 4, 3, 2, 1. It is option number C, guys. Refractive index, the absolute refractive index of a medium is equal to the velocity of light in vacuum divided by the velocity of light in that particular medium. So velocity of light in vacuum is given as C, and velocity of light in that medium is given as V, and N here is the refractive index. Next question, the last question. After this, I also have a homework question, but this is going to be an interesting one. The question is this: the refractive indices of glass and water with respect to air are 3 by 2 and 4 by 3 respectively. If the speed of light in glass is 2 into 10 to the power of 8 meter per second, then find the speed of light in water. Amazing question, guys. Options are 1.25 into 10 to the power of 8 meter per second, 0.25 into 10 to the power of 8 meter per second, 2.25 into 10 to the power of 8 meter per second, or 5 into 10 to the power of 8 meter per second. So here's the thing, guys. First of all, people, refractive index of glass and water is given. So refractive index of glass with respect to air is given as 3 by 2. Let me use a different color. Probably you might not be able to see it so clearly. Refractive index of water with respect to air is given as 4 by 3. All right. And speed of light in glass, speed of light or velocity of light in glass is given as 2 into 10 to the power of 8 meter per second. So here's the thing, guys. What we can do is we can basically find out what is the velocity of light in air first, then use that in order to find the velocity of light in water. So let me just show you how to do it. So for example, guys, if I want to find out what is the refractive velocity of light in glass, I know what is the velocity of light in air. I want to find out what is the velocity of light I know what is the velocity of light in glass. I want to know what is the velocity of light in air. So refractive index of glass with respect to air is velocity of light in air divided by velocity of light in glass. So if you substitute the values, that is 3 by 2 is equal to VA divided by 2 into 10 to the power of 8. Take this to the other side. So what will you get? So VA is equal to 3 into 2 into 10 to the power of 8 divided by 2. 2 gets cancelled. So what do you get? 3 into 10 to the power of 8 meter per second. This is the velocity of light in air. Now use again the refractive index of water with respect to air, well, a formula which is equal to velocity of light in air divided by velocity of light in water. So what is the refractive index of water with respect to air? That's 4 by 3 if I'm not wrong. 4 by 3 is equal to 3 into 10 to the power of 8 divided by VW. So take this to the other side. So what do you get? VW, that is velocity of light in water, is equal to 3 into 10 to the power of 8 into 3 divided by 4. So that's basically 6 into 10 to the power of 8 divided by 4. Sorry, 3 is 9. Sorry, 9. So that's basically, guys, to 2.5 if I'm not wrong. 2.5 into 10 to the power of 8 meter per second. It's not exactly 2.5, but roughly about that. 2.25, sorry. 2.25 into 10 to the power of 8 meter per second would be the answer. Sorry for the last calculation mistake, but yeah, that is the answer, guys. So that's how you do it, guys. So first thing what you have to do is, once again, just for those who have not understood this, I know what is the refractive index of glass with respect to air. All right, that is given as 3 by 2. The refractive index of water with respect to air is 4 by 3. Now, refractive index of the relative refractive index of a medium is what? Let me remind the formula. Refractive index or relative refractive index of the second medium with respect to the first one is velocity of light in the first medium divided by velocity of light in the second medium. So here also I did the same thing. Velocity of light in air divided by velocity of light in glass. So they've already given you the velocity of speed of light in glass. So use that in order to find the velocity of light in air. Once you use that, use the formula once again and find out what is the velocity of light in water. That's it. That's all, people. That was the question. This is your homework question. Try out the question for yourself. Find the absolute refractive index of benzene. The speed of light in vacuum is given as 300,000 km per second, and the speed of light in water is given as 200,000 km per second. So go ahead, baby. Go ahead, try out this question for yourself. Let me know what is the answer in the comment section. And yeah, people, the answer to this riddle is gaze at the let me repeat the riddle again. The riddle was this: gaze at the sentence for about 60 seconds and then explain what makes it quite different from the average statement. Quick, what is it? The answer, guys, is that this statement has all the letters of English language, all letters from A to Z. Every single letter is present in this language, and that is this particular statement. It has all of it. That is what is so special about this. How was the riddle? Let me know that in the comment section as well. So that's all, people. Once again, the Pro exclusive micro course. Once you enroll into the Pro subscription courses, people, you can take a look at this as well. You can be a part of this Pro exclusive micro course as well and learn with me. Right, guys? So that's all for today. Thanks a lot for joining. Do not forget to like, share, subscribe, be a part of the squad. Enjoy your life, stay safe, but at the same time, please take your education, your studies a little bit more seriously, guys, because your exams are approaching really fast. There's not much time left, and between this time till your first term, there'll be a lot of other tests coming up in your schools as well. So time is going to fly really fast. So please, please, please take it a little bit more seriously, right? So that's all for today, guys. Thanks a lot for joining. Catch you guys in the next one. Until the next time we meet, this is Anoop signing off. Have a great, great, great day ahead, guys. All the best. Bye-bye. Take care.